the laser industry specifically.
It has changed dramatically.
The field of biophotonics was just getting started.
The first instrument that I bought was a microwave spectrum analyzer.
It's time to shed light on our universe. This is All Things Photonics, a podcast about the physical science of light. Join us as we explore the latest in lasers, optics, spectroscopy, and microscopy. Each episode, you'll hear from leading voices from across the photonics landscape. We're brought to you by Photonics Media.
This is Associate Editor Joel Williams. Here are this week's top stories. Researchers at MIT built a device that they describe as a nanoscale flashlight on a chip. The device functions similarly to a spectrometer and overcomes a limitation of spectroscopy, namely size. The technology may one day find use in smartphones and other compact technologies. A team from the University of Rochester's Institute of Optics imprinted freeform optics with a metasurface, creating a technology that may chart a new course towards compact AR/VR glasses. The technology, called a metaform, is able to gather visible light rays entering the eyepiece from all directions and redirect them into the eye. A material developed and introduced by researchers at the University of Luxembourg will help robots analyze and understand their surroundings. The material relies on retroreflective spheres made from cholesteric liquid crystals, which turn into a solid state by the process of polymerization. According to the team, the material can be used to introduce tailor-made graphical information in the environment, which is invisible to humans but easily read by robots. Researchers from UCLA have demonstrated a class of optical materials that control how heat radiation is directed from an object. The advance could improve the efficiency of energy conversion systems and enable more effective sensing and detecting technologies. And finally, researchers from the Hong Kong University of Science and Technology developed optical tweezers-coupled Raman spectroscopy that can directly probe the structural features of alpha-synuclein, an intrinsically disordered protein, or IDP, that is closely linked to Parkinson's disease. Up next, news editor Jake Saltzman speaks with Claudio Mazzali, Senior Vice President of Technology and CTO of Corning's Optical Communications sector and a 2020 OSA elected fellow. I'm Joel Williams, and you're listening to All Things Photonics.
We're joined by Senior Vice President of Technology and CTO of Corning Inc.'s Optical Communications sector, a 2020 OSA elected fellow, and a member of the American Physical Society. Our guest has previously chaired the OSA Industry Development Associates Council, and in 2020 he served as co-chair of the FIO and LS Virtual Conference. It's our great pleasure to welcome Dr. Claudio Mazzali. Hello, Claudio.
Hello, Jake.
So I want to jump right into a very pertinent question now. 2020 was a particularly challenging year for obvious reasons. And in optics and photonics, we saw many companies shift their operations to the manufacture of PPE on the optics front. We saw thermal imaging companies devote their efforts to address COVID-19 and sensing and detection. I want to ask you how these shifts, even if they're temporary shifts, have impacted the optics and photonics community as a whole as we begin to hopefully move out of the pandemic.
Yeah, that's a good question. Well, I think that the pandemic, of course, impacted pretty much all sectors in every single corner of the planet, and I think some of them saw a very negative reaction. We usually talk about airlines and tourism and all that, but I think for us, specifically for this community, I think the large events, the networking events, the conferences, this is one that for sure it's critical for our community. I think get folks getting together and exchanging ideas and new ideas on optics, and the combination of academia, industry, all that. So those networking events, those conferences are super important for us, and of course we saw an impact on that. Some organizations try to adapt to that. OSA has been adapting and making hybrid events, but that's for sure something that create a little gap, I think, on the amount of conversation that was happening. but I hope that will come back soon. There are some other areas that I think it was an opportunity for optics and photonics to show once again the importance of this technology, the relevance. I mean, we saw in healthcare, we saw in different methods using optics for testing, diagnosing, and helping in fighting the virus. I think it was clear already for many of us the importance of connectivity and network in high capable transmission systems and high bandwidth systems, broadband, to keep us all together. And I think the pandemic made that more real and more clear to everybody, right? I think everybody sees now high speed or reliable connectivity, broadband connectivity, almost as utility, right? Same way that people get electricity and water, and they cannot live anymore without high-speed connectivity. And of course, optics and photonics is behind that. And of course, other technologies that are more mature, but that were critical during the pandemic. You think about UV lighting for decontamination and things like that. So I think we are still seeing what is going to come out of this. I think some of those technologies, they prove even more relevant moving forward. And some of the negatives, I hope, will get back to normal sooner than later. That's what we all pray for.
I want to ask you a question that hopefully your answer comes through an optical communications lens, and certainly you're equipped to go in that direction. How will you look back on the year, considering the advances and the setbacks? As we move out of this pandemic, it piques my interest how those in the industry are going to regard the year, given the good and the bad.
Yeah, it'll be an unforgettable year for sure, right? First, to show how fragile we are, right? And I think not only the pandemic, but many other things that happen within the different countries and the society that we live, this year was significant. And I show our fragility. I think some of the institutions show how fragile they can be, even the human body, and also even how we collaborate and how we look to each other as one, instead of separate groups, separate countries, separate teams. So I think that for me is an unfortunate eye-opening that we all have to realize. But of course, I think it also showed us that when we unite and think as one, we can solve problems and we can do things in different ways and we can be more agile and we can be fast. Again, unity, when we forget the boundaries, right, that helps a lot. Specifically with the lens of telecom and optical communications, I think it was interesting because first, we realized that this specific area is very critical, much beyond just the services that we keep thinking about, right? I told you a minute ago about, becoming a utility, become something that people depend on, something that people rely on to work, to connect with their families, to educate their kids, to help each other, right? So this is just amazing. Now, throughout the year, we had to go through many barriers and surpass those barriers in different ways. Supply chain, for instance, was impacted significantly. And then there were creative ways to go around those things and people collaborating and working with each other. Some other things became more clear, dependence on low latency in some cases, dependence on some other areas that before were not viewed as that critical. The supply chain that I said, the supply and demand, it's interesting because also that brought another perspective in terms of interdependence, different countries, different regions versus what you can get next where you are. That also created the need for other collaborations and people working with things that before was not possible for them, either for a business case or, when you get into a situation like a pandemic, business case becomes irrelevant, right? You think about people first, you think about your employees first, you think about safety of your employees and your families first. And that sometimes opens up opportunities and ideas that before there was not enough attention around them. Networking capacity was an interesting thing because we saw that when you have a capable infrastructure, you have more ability to react fast. And that's where optics and photonics, I think, show their power there, right? Today in the world, we have networks of different things, right? All the way from DSL, copper cable, then truly optical networks. And it was clear that the places where the optical infrastructure photonics and optics infrastructure was already present, it was much simpler, much easier for the carriers, for the network operators to react. And in most of the cases where they had that fiber there, where they had that optical infrastructure there, actually they were able to manage the increase in demand without much problem. Of course, they had to eat a little bit of their buffer that they had at the peak, but once the media, right, once the way that you're transmitting the information is so capable, like optical signals in fibers, lasers, etc., the ability that folks had to manage that demand was there. That's why we didn't see a lot of complaints about problems with bandwidth or problems in being able to connect with your Zoom meeting or your WebEx meeting. It was, I think, before we went through this here, I think people would assume that the problem would be much bigger from a network perspective. But I think because of the amount of optics that's there, in my view, of course, I'm totally biased on that.
I was going to say, yes.
I'm totally biased on that, but I was glad to see that what we have been talking for a while in terms of being ready for the future, but also being ready for a year like this, it proved to be true, at least in the lenses that I have.
Yeah, it's a great answer, and one of the things it touches on is this aspect of globalization, and you talk about it through a fiber optics lens in particular, and telecom and datacom, and we mentioned your roles, your involvement with OSA in the introduction, and one of the most outwardly apparent, and it sounds inwardly apparent, growth areas across the whole of the optics and photonics landscape is this globalization of the industry. And it's a core element of OSA's mission, but it's also a point of pride, and rightfully so. I want to ask you, what do you believe has enabled the industry to achieve such profound and evident success in globalization?
Yeah, that's interesting. Well, I think you gave already half of the answer. Again, that's another piece that I'm biased because I'm a big fan of the work that the Optical Society does, and they truly spend most of their time in resources and making sure that they spread the world or they spread the gospel of optics at different levels. And so I think OSA is playing a very critical piece here, but not only OSA. There are other organizations and others that also help with that. But I think, number one, right, when you connect academia, industry, government agencies, and some other players, that is fundamental for globalization, right? Because sometimes, depending on which stage the technology is, you may have a concentration in one country or a set of countries, a more developed countries, but academia is something that's more distributed. And if there are organizations, OSA and others, that do that work, and you start bringing that talent from different locations, from undergrad and even before undergrad, there are even programs on high schools and middle schools bringing the beauty of optics, the beauty of photonics to young brains, right? That sticks there and that propagates, and at that age, right, that's when you create your passion in building that talent globally, not too concentrated in one country because that's where you have the resources or that's where you have the big companies or that's where you have the big labs. But building that talent all over the world is critical for that. Those folks, they move around. They may become part of those big companies and big countries, but they go back to their countries. They share ideas in conference. So that's one of, I think it's so critical. There's one other aspect that I think that is totally connected with the technology itself. When you think about optics, and let's talk about modern optics or more recent optics, I think ability to have your light source is very critical, right? In the past, if you think about the 50s and even before that, it was not that, or 60s or 70s, right, when lasers start, was not that simple or that cheap or that affordable to have a laser in people's labs, in universities, or in other in the small companies, the startup companies, or universities in the developing countries. I think when you think about the evolution of the lasers and industries like lasers for industrial applications, more high-power lasers, or even if you go to telecom, those industries, they were fundamental to create the volume for that technology. So now you are able to afford either a high-power laser or a telecom laser, right, a semiconductor laser at a very low cost, and all the subcomponents that goes around that. So you got your fundamental pillars that you need to have a lab in university, to have a startup and playing with some ideas that you can afford that technology. I think there are some big parts of the industry that help with that volume and reducing the cost, make things more affordable, and then enabling those things to start in many different locations. Same thing with other parts of telecom, right? You think about the volume in optical fibers and other things. That all play in reducing the cost and making it more available to people around the globe to play with it, to enjoy other ideas, to try different things, and that's critical. So I think there's this two perspectives here, right? One is more connecting the academia and in the industry and government and etc. OSA plays a key role there. But I think the technology itself and how it has been evolving has made a big contribution for that. Other than, again, the beauty of optics, right? It's a field that if you're there in optics and photonics and you see that the beauty behind all the phenomena, all the physical phenomena there, it gets to you and it's difficult to it's difficult to escape.
So we have this multi-pillared approach, at least two pillars, academia and industry, and you mentioned the third, government. And one of the things that spins out from that, you said startups, but first maybe we should talk about entrepreneurship. What are some of the things that have helped entrepreneurship in optics and photonics flourish from early career stages to more established professionals?
I think optics and photonics in general, at least during the last few decades, it's probably one of the areas, the transition between the fundamental science to a real product. It's actually quite fast compared to some other technologies, right? If you look into some other areas, I think it takes a little bit more embryonic time to get things from a totally new idea or a totally new concept or a totally new device to become something that you can see in a store, right? Today, when you look into the amount of optics that you see in a cell phone that you carry in your pocket, is almost shocking, right? It's unbelievable. And some of those technologies, they were in research papers just a few years ago. I think that fast transition between fundamental optics and photonics to real applications, real world applications and real products that people can buy and enjoy, it's critical because that's part of what's on the brain of entrepreneurs, right? They want to bring things to the real world as quick as possible. And then when you connect those two pieces, fundamental science, fundamental optics, to a product in a quick time lapse, that for sure helps. I do think that another thing that helps not only optics and photonics, some other areas as well, is there are some adjacent technologies that have gone through this similar fast-paced evolution. You think about electronics, you think integrated electronics and software. Those are, they're always there. They need to be next to optics and photonics to transform those fundamental ideas into products. And those areas have also been evolving very quickly, right? Software and integrated electronics. I think that's very important. The third one I would say it's probably the fact that people don't make, at least often enough in my view, they don't make a connection between optics and information. But that's something that I keep thinking about, right? Optics is at the core of information. How you're obtaining information through sensors or through different ways of gathering data, that goes through optics. How you're transmitting information, and we just talked about networks and optical communications. How you're visualizing information in displays or different types of displays. When you think about holograms in 3D and 3D video and all those different things, and now with augmented reality and virtual reality. So optics is extremely connected to the flow of information in our society, all the way from starting getting the data, getting the information, all the way back to getting to our eyes or any other way. And I think we are living this information society right now that everybody talks about. I remember some time ago I wrote a little piece about I think I called bits and photons or something like that. And it was all about this, right? That the photons, they give this superpower to the bits, enabling the bits to be anywhere at any time. And I think if you look at the visibility of software today and what software does in our society, they got an unfair share of the visibility, right? I think everybody talks about software, everybody talks about the apps, everybody talks about the web services or the social network things and etc. That's all about bits. But those bits, they become really very, very powerful because of the photons that are carrying those bits and making that a global thing, making that look like it's always next to you, doesn't matter the time or the location. So I think that connection between information in optics and photonics, I think it's also pretty important in this, together with other things that I mentioned before.
Joining us is Claudio Mazzali. He's Senior Vice President of Technology and CTO of Corning Inc.'s Optical Communications sector. So we've talked a little bit about, not to put words in your mouth, but we've talked a little bit about this talent pipeline, only tangentially. So I want to ask, what can we do from within the optics and photonics community to generate interest in young people in the career avenues and access to technologies and promise of the field?
Yeah, as you said, we talked a little bit about that. I think this fast transition between fundamental optics and products that you can see in stores or in applications today is very important. I think that when I think about myself or even other folks that I know, right, I think there is usually two, of course there are many, but there are probably two main pathways that people pick their profession, right? And again, there are many, but let's simplify. I think you can probably separate all those into two beings, right? One is really driven by passion. The other one is really driven by, okay, which job can I get a good salary, right? And financially, I think that fundamentally, at least today, right, optics and the folks that goes into optics, etc., I think they are more in the being of the passion and the being of, okay, this is something cool. And sometimes when I say that, it's something cool, people say, well, that's such a naive way to look at this. Well, but you need to think about the time that you're making that decision in your life, right? You're making a decision about which career you're going to follow at the time where actually what matters to you is what's cool, right? You're in that age that you're thinking about how can I have fun on this. And sometimes we kind of dump that and we say, well, you need to pick something that you're going to make money, and etc. Optics is something that people usually come from that. This is cool, right? I want to play with lasers in the lab, so that's why I'm going to work on that lab in my university. That's why I'm going to pick physics or optics or something like that. And I think those are the ones that from the beginning they stick with it, and it's very difficult. Somebody that sees that passion then moves away. The other side, the ones that you're thinking about your opportunity in job market and all that, that's where I think when we make that fast transition between new technology in optics and real products, that's when you make that more visible. You make that, if you have that background, if you're working on that, you can create a LiDAR company for the automotive industry and become really successful financially as well. I think those two things could be important. I think we can help on those two areas. I think we talked a little bit about the work that OSA does and some other organizations too in helping the connection between academia and industry. I think that is super important, again, to connect those two sides that I described about. The third leg or the third pillar here with government is because some technologies, some early stage technologies, there is a longer incubation period until they become useful or cost effective or whatever area they go. And that's where government and the strategic programs are super important to fund that and to bring that to a stage where then the private sector can invest and do that. I think we saw that in the space program. I think we're going to see that in quantum computers and quantum communication. That's becoming, again, talking about quantum communication just for a second, right? This is something that's right there, exactly in between something that's extremely fundamental, extremely in the science domain right now, right? People are still discovering what can be done, what cannot be done, and what can be practical, cannot be practical. And at the same time, all the discussions that are happening about, network security and privacy and ability to communicate in a secure way, brings quantum communication to the realm of a real product or of a reality that is going to be in our lives pretty soon. When you add quantum computers to that, you see that, well, when quantum computers become more readily available, classical cryptography, classical encryption may not be that secure anymore. So you're going to need some sort of quantum encryption, quantum cryptography, and that's where quantum communications becomes interesting. So it's an interesting example of something that is extremely fundamental and can be super real sometime soon. those are things that usually bring the young brains a lot of interest, right, and a lot of excitement. It's something cool, and it's something that can be important. So I think that's how we can help making those things a little bit more clear, right, and demystifying a little bit the science, demystifying a little bit, not hiding the beauty of the science, but making sure that people understand that is something that can be real in their lifetime.
You touched on it a moment ago, and it's something, too, that we've touched on with our guests in previous episodes of All Things Photonics. And that's looking at electronics, for example, and seeing the evolution of technologies in that realm, and then sort of being able to forecast what's happening now in the photons time. And we've done it through a more materials lens and maybe a supply chain lens. We've talked about graphene in the past on the podcast and silicon as well. But when you're communicating with government, when you're talking about technologies such as quantum that are right there, I'm curious what the message is to government, because obviously there's a ton of potential, but you have to go in, I would imagine, with a little more than that. I'm just wondering what might be the message that you're conveying when you're trying to play up the significance of these technologies.
Yeah, and I have to be honest, right? It's not easy, and I've been in some of those discussions. It's not easy. So a big part of that is educational, right? A big part of that is making sure that people have this true understanding of the challenge that we have, of the boundaries of different technologies. There are things that, for instance, people are used to a different technology to solve a type of problem. And if you're not well educated, if you don't know exactly what's going on, you may just assume that solution or that technology is enough to solve that kind of problem forever. So that's a piece of the education that you have to show. You have to show the limit. Instead of only talking about optics or photonics in the cases where you're going to talk, usually you have to start by talking about the limitations of the boundaries of other technologies that are solving that problem today. I just mentioned the classical encryption versus quantum encryption, for instance, right? You need to show that, hey, look, yes, classical encryption is working today, but this is what can happen once quantum computers are available. And then what's the next way that you're going to solve this problem, perhaps with quantum communications? Same applies for other things, right? You think about 5G, for instance. 5G is one of the buzzwords that everybody talks about, and everybody thinks about wireless. Well, when you look into the amount of wireless and the amount of optics that goes under the 5G umbrella, I would argue that there is more optics there than actually wireless. At the very end of the network, you got an antenna, and that connection to your mobile or to your car is wireless. The infrastructure for 5G behind the scenes actually never been more optics there. I think the wireless network was never as optical as it's going to be when you move to 5G, and that's a combination of many things. It's a combination of, well, you're going to have more bandwidth in 5G, and guess what? You can only achieve that if you have all your antennas connected with optics, with an optical signal coming to the antenna. Then, well, if you want that high bandwidth in the wireless domain, you're going to have to go to higher frequencies, right? So that we keep hearing about millimeter wave and things like that. Well, guess what? Millimeter wave doesn't propagate that far as low frequencies. So then your antenna needs to be even closer to the user. So now the optical signal needs to propagate even more. Then you think about all the new services and all the new data that is flowing through the 5G network, and you go to the core of where those data is coming from, and it's from data centers, major data centers, hyperscale data centers with more than 100,000 servers in a single building. And when we look into the latence and we look into the interconnectivity that you have to build into those data centers, pretty much every single server is connected to another server through an optical link. And that is also because those data centers, they don't look anymore like they used to look in the past, like a storage farm, right? Where you want to see your bank account, it's stored in one of the drives there, and the data center is just that. Now a data center is a supercomputer, right? It's a supercomputer. Those servers are always doing AI algorithms and machine learning and getting information from different places and creating a totally new set of data as you are querying for this data, right? People give the example that when you look into your friend's Facebook page, whatever picture he put there with the tag, all those things are in different servers. And when you click to look at that page, that information is coming from different servers and creating that page in front of you at that time. And if you click again a minute late, it's going to bring the information from other servers. So that creates a need for interconnectivity that needs to be fast, it needs to be low latency, and by the way, you can do that only with optics and optical signals and photonics. So I think that's what you need to do, right? It's not only about talking about optics, it's talking about, world is changing. The way that's changing is eliminating some other solutions that we had in the past that were just fine, but they don't work anymore. Your DSL line is not enough for you to have your 3 kids having online classes, right? We talk about the pandemic at the beginning. So you have to show that. You have to show the limitations of non-optical or non-photonic technologies first to then show that that's the right tool to solve that problem. And I think that's not unique to optics and photonics. I think it's for all new areas. And I think the one thing that's happening with optics and photonics is that the optical community, academia, industry, we are becoming more relevant, right? The relevance of optical technologies in general, it's growing fast. I mentioned LiDARs, right? And again, autonomous vehicles, when you think about maybe LiDARs and cameras and all that will be super important for that. We talk about healthcare and optical diagnosis and other optical technologies for healthcare is becoming more and more important. Telecom, and all those things, right? So we are just becoming more relevant. And I think that what I noticed, you asked specifically about talking to the government, it was more difficult a few years ago. It was more difficult to justify. It was more difficult to convince people a few years ago. I think because of this increase in the relevance of the optical industry, the optical community in general, those conversations are becoming simpler. And we can see not only here in the United States, the U.S. government, but many governments around the globe, they are paying more and more attention to this community and to this technology.
I want to ask a question now that pivots the conversation a little bit, and I hope it takes advantage of some of the optical biases that you've outlined for us earlier. And, we're tremendous focus right now on the performance capabilities of optical fiber technology and enhancing those capabilities. I'll reference some recent advancements from the University of Southampton demonstrating the ability of new hollow core designs to withstand very high lasing intensities to the point that those fibers are performing much the way a solid glass design might. Also a demonstration of the ability of NAMFs to stabilize resonator fiber optic gyroscopes, which certainly have some interesting applications in defense and directed energy. With all that taking place, I'm hopeful that you can identify some additional trends in optical fiber research that we might be smart to keep on our radars.
So, well, the one that you mentioned is for sure a pretty interesting one. The folks in Southampton, right? Professor David Richards, Poletti, of course, David Payne. They have been working on this for a while, and they have been doing a fantastic job. And they just, as you said, presented some results recently that are pretty nice, reducing the attenuation of hollow core fibers, the anti-resonant, right? The NAM for anti-resonant fibers. It is hollow core fibers. It's not new. Hollow core fiber is something that people have been working for a while. The anti-resonant approach that they have been working more recently is actually pretty interesting, unique, new, and of course the entire community is excited about that work. There would be some concerns or issues when you think about, and when I say concerns and issues, I don't want to say anything negative. I think the work that they are doing, the work in this space is fantastic. We are doing something as well, and I think the industry will all play in this space. The challenge there, it will move quickly at some point. Again, I was talking about bringing fundamental to practical application as fast as possible before, right? We can apply to this case. When you work in fibers of that type, if you think about field installation and installation in open spaces or for telecom applications, that's where some of the challenges will be to make the system robust, make the system easy to install, making the system independent of contamination, other things. But those are engineering problems in my view, right? Those are not fundamental problems. Fundamentally, the solution works. Now the community, again, needs to get together and start collaborating to solve the engineering problems to bring that to reality. I'm making this just to make a hook to your actual question, like what's coming or what is the key challenge right now, other things, other trends in fiber. I would say there are two major trends. One is in what is the most efficient way of increasing the overall capacity. And it's a tricky situation because the capacity of an optical fiber is already humongous, is already huge. But even with that capacity, we see today cases, I mentioned data centers recently, there are cables in data centers interconnecting buildings in the same campus of a data center that in a single cable you have more than 3,000, 4,000, 5,000 fibers in one single cable connecting buildings. And you got problems there in terms of, okay, how can I make that more efficient? You can play with different ways to transmit the optical signal in those fibers to increase the capacity. You can play into reducing the density increasing the density of that cable, and you can do that with smaller fibers. You can do that with multi-core fibers, so several cores into the same fiber. You can do that with a few molded fibers or transmitting several modes into the same fiber. So that's one of the trends, right? How can I put more data, more information to the cable, not in the fiber itself, but in the cable, so you can play with either different amount of fiber or more bits in each one of the fibers. That's one of the key areas that the industry is working on. The other one has to do with that practical implementation. If you ask a carrier, a network carrier, right, a service provider today, what's your number one nightmare? What's your number one problem that you have today? I think several of them will tell you, well, it's permits to deploy cables, is ability to deploy optical fiber fast and everywhere that I want. I want to put more fiber in the ground, but it takes too long sometimes because of permits, because of ability to dig holes in the ground to deploy the cables. And so there is a lot of work coming from the industry to make those things simpler, easier, faster to deploy. I would argue that for some specific applications, it's probably easier today to deploy optical fiber than to deploy a copper cable, believe it or not, but it is in some cases. And more work is happening into that domain. How can we make this optical technology that is much newer than a copper wire, is much newer than a copper connector? How can I make that simpler, easier, cheaper, that the field installation crews can actually deal with that in a way that they don't even know that that's a piece of glass there. They don't even know that there is an optical fiber there or that there is a laser connected to that. It's just something like a regular cable that they deploy in other places. So I think those are the two major areas that the industry has been working on. Of course, I'm talking specifically about fiber. When you look into the other optics and photonics elements that will enable all that, then there's a lot of other cool stuff. One that I have a particular interest on is when you think about nanophotonics or nanosurfaces, very, very small elements in surfaces that you can basically replicate most of the optical components that you have in bulk to them, lenses and splitters and wavelength selectors and all that today are bulk components. You could do that in a micro scale and miniaturize things and automate things and actually handle the optical signal in a totally different way. That's one that it's too early, but I think it's probably poised to be one of the major transformations that we're going to see in this industry in the next few years.
Our guest is Senior Vice President of Technology. He's also CTO of Corning Inc.'s Optical Communications sector, Claudio Mazzali. I want to end with a question that I think is of particular interest to our listeners and also the readers of our magazines. We talked a lot about applications, and rightfully so, but I think it's important that we not get ahead of ourselves, and I want to ask, what's the message? What should our listeners and readers know about the current state of the supply chain with regards to optics and photonics manufacturing?
If you're asking for a message, I think that we are collaborating, and I think that needs to increase even more. I think we are in a phase right now where different parts of this ecosystem, the ecosystem of optics, in optical communications and in other areas as well, I think we're going to all win together with even more collaboration. I'm not saying that we have a problem there. I'm saying that this is actually, I feel good where we are in terms of companies and academia and others being open to collaborate more. But I think we're going to need to accelerate this evolution. And that's how we're going to make this community and this industry even more relevant, as I said. And my message is that we need all to be open for that. More collaboration among the different players. That's how we're going to help each other solve the problem. We are not at a moment where one element of the ecosystem can solve the entire problem. We're going to have to work together and making sure that we look at the problems that we have to solve from different perspectives in attacking that problem from different sides. And that's how we're going to all help each other. It's almost the theory of the commons thing, right? Don't try to hide your tricks and try to solve the problem yourself. I think we all be in a better situation, and the entire society will be in a better situation if we collaborate even more. I don't think we're far from that, but if there is one thing that I would like to see even more, that's what I would like to see even more in the supply chain and ecosystem.
Claudio Mazzali has been our guest today. Claudio, thanks for joining us. Really appreciate your time.
Thank you. It was great.
That does it for this episode of All Things Photonics. Thank you to our engineer, Alan Shepard, and to Joel Williams with the news. Our featured music is courtesy of betterwithmusic.com. Most of all, thank you, our listeners. As always, you can share your thoughts, pitch us ideas, let us know how we're doing. You can reach us at allthings@photonics.com. All Things Photonics is available on all major platforms, including Spotify, Apple Podcasts, as well as on our website. Subscribe, never miss an episode. I'm Jake Saltzman. This has been a Photonics Media production.